A global problem that can be felt on a local scale is pharmaceutical pollution in our fresh water. Let me explain. When people take pharmaceuticals such as painkillers, birth control, and hormones, they will eventually exit their body in their urine and unfortunately are not filtered out by the current wastewater treatment systems in place, hence entering our freshwater systems. While this isn't a problem in Vancouver, this is a much greater problem in Toronto, where approximately 470 grams of pharmaceuticals enter Lake Ontario every day, which are then taken up by freshwater plants and inserted into the water system. This paper looks at a cost-efficient and feasible way of degrading these pharmaceuticals using ibuprofen with a photocatalyst and UV light, which would break them up into less harmful substances and eventually mineralize them into CO2 and water. The way this works is that when the high energy photons of the UV light make contact with the electrons of the zinc oxide photocatalyst, they become excited and rise from the valence band into the conduction band, eventually escaping the molecule and then interacting with dissolved oxygen and water molecules in the solution, facilitating the reaction, hence creating reactive hydroxide ions from the water and reactive oxygen species from the dissolved oxygen, which then, in a method of preferred attack, degrade the ibuprofen. This paper also has developed into a secondary research paper which has now doped the zinc oxide catalyst using titanium, copper, and iron, which increased the electron-hole recombination rate between the electrons in the photocatalyst, which eliminates the main inefficiency of this process, as explained in this paper, as well as the first paper, which are both in the description of this video.